So, 3 years ago, the people at NASA took a picture of a black hole. Amazing. Now, the biggest question here is, of course, how do you take an image of a black hole with one telescope? And how large would this telescope be? Well, the answer to the first question is there were 7 telescopes, actually. They were all operated by the Event Horizon Telescope, and the 7 telescopes are located in Arizona, Mexico. There are 3 in Chile, there's 1 in Spain, and there's even 1 at the South Pole, which I assume is for visibility. So, on the Event Horizon Telescope's website, they describe themselves as a virtual Earth-sized telescopes. Is this true? Well, let's see. So, how large would these telescopes have to be in order to get an image of a black hole with a radius of 4.2 centimeters, which is how it appears on my computer screen? Well, specifically, how long would the focal length of this telescope be? Because gauging the actual size would be extremely complicated, and I don't have time for that. So, the focal length is f. And this black hole is around 53.5 million light years away from the Earth. So the object distance is 5.061 times 10 to the 23rd meters. Yes, there's a complication of whether the telescopes are on the side of the Earth closer to the object or away from the object, but that's such a small difference that it might as well not matter. So the image distance, d of I, satisfies 1 over the object distance plus 1 over the image distance, d of I, is equal to 1 over f, meaning d of I equals 1 over the expression 1 over f minus 1 over the object distance. So the magnification factor, m, would be negative 1 divided by the expression, the ratio of the object distance to the focal length, minus 1. So the ratio of the radius of the black hole in real life to the radius of the black hole's image would be 1 over the expression, object distance over focal length minus 1. So, since the radius of the black hole, including the accretion disk, because that's important, is around 1/100th of a light year, which is 1.041 times 10 to the 14th meters, by the way, the radius of the black hole on paper would be 1.041 times 10 to the 14th, divided by the expression, the object distance divided by the focal length, minus 1. Since the radius of the image is 0.042 meters, which is 4.2 centimeters, we get that the focal length is around 200 million meters, and the Earth's radius is about 6 million meters. Yeah, quite a bit larger than Earth-sized.